Hello everybody, today I am going to talk about signals and slots, and let's talk about motivation, why we need signals and slots, and talk about different approaches how to solve different design problems in a kind of a classic old textbooks way. So let me make directory, go to lab. For some reason my hard disk is very slow. Signals, slots. So the classic problem is we have some sort of library and we want to communicate from library with user code somehow. And classic example, it's widgets in graphical user interface, and let's say we have some class button and this button kind of interact with existing code, like we can instantiate the button, right? And we want to do some useful things, some user code. We want to run some user code from like a click on button, right? So there is different approaches to attack this thing, and one of them it's inheritance, right? So we can have some virtual method click, for instance, and then we derive from the class button, like my button. And I forgot how it's in C++, it's overload or override. I think it's override, void clicked, and we can do our implementation, something like this, right? I don't know, would it compile? Let me compile it. Should I put it after? Right. So like this, and the problem with this thing, for each button we have to make each class, and if we have like 10 buttons which we would do different things, we would need to make 10 different classes. So in our way to do thing, it's to have some click handler class, base class, right? Like base click handler, and here we will have virtual, and also we can have like not for particular click handler, right? We can have some interface, and then button will take click handler like this, and it will store it somewhere, and then we need this thing, we will invoke it, right? And same thing, we kind of derive from click handler, my click handler, and do our implementation. So we can like instantiate button, we can make my and pass it to button, something like this, and inside the button we can have generic code. So this approach is a little bit better, but still for each handler we would need to derive from click handler, so which is not very convenient. So modern way to do this thing is to do with signals and slots, but C++ doesn't have signals and slots like out of box, and there is a different like Qt have implementation of signal and slots. There is a Boost have implementation, and Microsoft Visual Studio also have some sort of an extension in the language to implement signals and slots. They call it delegates. And my advice for you, just implement this thing by yourself. It's actually very simple. So so what is signal and slot? Slots basically it's method in your class, and signal basically pointer to this method. And you can think about this thing as pointer to function in like C, but method actually takes some extra parameter. It's pointer to the class, this pointer. So I kind of want to have very efficient version of signals and slot, and do not want to have a lot of different types sort of features in my implementation. And basically in most of the cases we need this sort of signals and slot implementation. So let's start let's start implementation for signals and slots. So I'm going to make some concrete implementation and then move to some generic implementation of signals and slots. Okay, so we have kind of two things, right? It's signal and slot, and basically we decided slot is just a method. So what is class signal? So we have class signal, and what kind of interface for class signal we want to have. And we want to have a way to invoke the signal, and it's the best thing is just have operator, function operator, right? So and it will take some parameters for now, and it will return something, right? Let's do with integers, so it's kind of will help us to kind of wrap around our mind around things, because like taking nothing and returning nothing, it's not kind of a generic case, it's more like a corner case, right? Another thing, we want to assign slot to signal or connect signal with slot, and we can have some function outside, or we can just have some assignment operator. And you know, let's do assignment, right? I think it feels kind of right. So let's have operator assign. And you know, as usual, I don't do a lot of preparations for my video, and one of I think it was on Reddit was complaining about this thing, but I just don't have too much time to do preparation. So it's basically right now I'm writing the code. I was thinking how I want to do things, but I never made the implementation what I right now have in my mind. So assignment operator, okay, they're equal, and it's going to take pointer to object, some object. I think it's going to take pointer, right? Let me think. Yeah, so it's a pointer to object and pointer to method, and method going to be int object pointer, and it's going to take int, something like this. Declaration of operator as none. I cannot do, oh right, I cannot it's funny, yeah, I cannot do equal because I need to take object and there is no information about so let's do connect. Okay, so as we decided, it's going to have pointer to object and it's going to have pointer to method. You know, like, let me type def it. Type def method. So method is going to be quiz. So let's have class object, and I don't like name object, because object it's a class, and let's call it t. Okay, so, and it will have method 1, method 2, method 3. Okay, so t. So I'm going to remove this code, and let's do implementation for all these things. So I'm going to implement class t, cout, and x is going to do +2, and this is going to do +3. So now these things I'm going to assign null pointers. So if there is no slots connected to if no slots, I would not call anything. So I'll do check here. If object and method, I can call it object. So object is a pointer, so I'm going to call method with x like this, and I'm going to return this thing. Otherwise I'm going to return this thing, x. Should I do it like, yeah, I need to do it like this. So here is it. So my kind of non-template implementation is ready, and let's test it out. So we can have t, and then we can have signal s, and then we can connect t with tm1, and then I can do cout s10 like this. Do I need to do it like this? Right. You know, I don't want to, so let me make this thing. No, I cannot do it like this, right? Can I do it? No, I can. I think it's fine. So m1, m2, and m3. Connect didn't work because I did not implement it. So object and method. So objects equals m. So and actually it was good test, because if we did not connect anything. So m1 11, m2 12, m3 13. And why it's printing x? Oh, slash n. Yeah, x slash. Let's do it like this. Come on, do nice things for me. So of course this is not full implementation. We need to apply a bunch of templates, and one of things, if I have like class u, and I have a bunch of methods of class u, and I have u here, I cannot connect u. It would not let me connect u class to my slot. So first what I need to do is generalize connect, right? So it's template type name t, and this, let's move implementation from here to here, and it's O and M. Okay, but we cannot do this thing because point. We cannot do this thing because come on, so I don't need this thing. Let me call it type. I think I have type collisions, right? Int t : star, method int. It does right. It does work because because of this object t and like but it doesn't work. It still doesn't work for you. So what I can do, I'm going to be dirty. So I would do this thing and this thing. Okay, and then I will cast. How I know? Actually, I do not need to know. I need to cast method. Actually, right. I can make the int any random object. It might be t. Fine, int. And actually, I can make the object t too. And like can make the class t here. Just doesn't have anything. And then I can just cast like this. Can I do type def here? Type def int t. Wait, right. Int t star m int. So I want to cast to m. Nice, it did work. So I just need to implement these things. Let me just copy paste it. Say these things you. It does compile, so I'm going to print the class name here. So let's see, would it work? It did work. Let me do for you, like I will add a little bit more. It did work. Cool. So, and you can see implementation for signal is small, and actually I can move all these crazy things down. So, but it's not very generic because for instance I want to have method m2 taking 2 parameters int, right? And it would not work. Okay, so we need we can have different signals with different signatures, and it's going to be specified, like I'm going to convert this class, concrete class, to template. So and it's going to be return parameter and input parameters, right? Type name, like argument parameters, argument types, like this. So next here it's going to be return, and this integer going to be turned to arguments. Do I need to put 3 dots, right? Arguments. Then so what the matter with t? Yeah, I have private class t, so it's going to compile, and this is going to be return, and this is going to be arguments, like this. Here same thing, return arguments like this. This is fine. Turn. I think I need to put 3 dots here. Okay, and then I'm going to move implementation here, checking for null pointer and invoking this thing with args. I think that's it. So now I'm going to have int the slow signal, which is and then I can have another signal which will take return integer and take 2 integers, s2, can connect to s2 and invoke s2, right? So let me modify m2, and I'm going to print out x plus y and print y here. Awesome, it works. So I'm saying don't use library, this is a whole implementation of signals and slots in modern C++ and C++11, and it's as much as possible efficient. There is only one check here for null pointer, like this one basically is overhead, and everything else is efficient. I use some dirty hacks here, like doing like casting to class T, but I think it's going to work everywhere if I correctly understand the implementation of how like C++ compilers work inside. I did not test, of course, on different compilers. I just tested it on GCC, and of course if we want to use it in production, we need to test it. But look at this, it's awesome. Like, why you need to use libraries? Like, why you need to use what the library, Signals tool or something of Boost, which is like freeze your compiler for several seconds every time then you compile your source code, and you let us things like, oh, what's going on, like my compiler crashed or something. So thank you for watching, and hopefully see you next time. Bye.